All right, now that we have the domain and range for the inverse functions, let's actually take a look at how we actually can evaluate inverse trig function values. Again, in practice, it's going to be very simple, but what's really the issue that we need to be careful about is these particular values over here. Okay, so pretty much to evaluate inverse trig functions, we're just going to use our chart in reverse. It's really that simple. Okay, so if nothing else that we've said has made any sense, this is really the important takeaway. That if we're going to evaluate inverse trig functions, we're just going to use our chart of values that we know and apply it in reverse. The only thing that we'll need to watch out for is when we have negative values going into our inverse trig functions. Okay, that's what we're going to have to watch out for. That's when we end up having to use these guys right here. So I'll make a note of that here. These are only when negative numbers go into the inverse trig function. Okay, so we'll see that in a minute. Let's just look at a couple and see how simple this really is. Okay, so remember, a trig function goes from an angle to a ratio. An inverse trig function goes from a ratio to an angle. So if I'm going to use or evaluate inverse trig functions, that means I'm going to be finding an angle. For example, if I ask you to find theta equals arc cosine of the square root of 2 over 2, or I could even just phrase it as find arc cosine of square root of 2 over 2 is the same idea, right? And so what we mean by this is we want to know what is the angle that is that has a cosine function value of square root of 2 over 2. So another way to say this is the angle whose cosine value is square root of 2 over 2. And from our chart, we can all really quickly and easily say that that is 45 degrees. Or, as you've memorized it in radians now, hopefully remembering that 45 degrees is pi over 4. You need to be able to answer or give the angle in either degree or radian mode. If the directions don't specify, you can give it in either. That's fine. Degrees is totally fine. Radians is fine. However, on a quiz or a test, if the directions say give the angle in radians, make sure you're ready to give the angle in radians. So you can memorize the chart in degrees and then convert to radians every time, or you can memorize the chart in radians as we did, hopefully we did last week. But either way, the question itself here is relatively straightforward. Inverse cosine or arc cosine of square root of 2 over 2, that is the angle whose cosine function value is square root of 2 over 2. And that angle we know is 45 degrees. So we've talked about this one a bunch already. If I ask you what's the arc sine or what is the inverse sine of 1/2, taking a moment to think about it for a second. Really, again, this is asking what is the angle whose sine function value, is 1/2. That angle is, of course, 30 degrees or pi over 6 radians. Okay. So again, it's really pretty straightforward. All of that domain and range stuff is confusing, but the actual operation is really straightforward. We're just reversing finding the exact trig function values like we've been doing. Okay. Now what if we have a negative value? And this is where it gets a little bit confusing. So if I said find arc sine of negative square root of 3 over 2. Okay, so this is where it gets weird, but it boils down to, coming back up here, it boils down to if we're looking at sine, inverse sine, or inverse cosine, we just put the angle into quadrant 4. And to do that, all we have to do is negate the angle, and it's automatically in quadrant 4. So for arc sine and arc tan of negative angles, or negative ratios, we'll just negate the angle. It's that simple. We just need an angle in the 4th quadrant. So for arc sine and arc tangent, that's all we have to do, just negate the angle. For arc cosine, we see that our angle needs to be in the 2nd quadrant. So this is a little bit weird. For arc cosine of a negative ratio, we just put the angle into the 2nd quadrant. We'll do one to make sure we see what that looks like. We put the angle into quadrant 2. So for arc sine and arc tangent, if we take arc sine and arc tangent of a negative ratio, all we have to do is make the angle negative. For arc cosine of a negative ratio, we're going to take our regular angle and move it into the 2nd quadrant. Let's look at a couple. Okay, so I said arc sine of the negative square root of 3 over 2. We said arc sine, all we have to do for a negative ratio is move the angle into the 4th quadrant by negating it. So what is the angle whose function value is square root of 3 over 2? Well, we know that that is 60 degrees, or pi over 3 radians. But because it's negative, for sine and tangent, all we have to do is make the angle negative. And that gives us an angle in the 4th quadrant and satisfies the arc sine function. Again, for arc sine and arc tangent of a negative ratio, we just negate the angle. That's simple. What if we took arc cosine of a negative ratio? Say arc cosine of negative square root of 2 over 2. Well, we already did arc cosine of positive square root of 2 over 2. And remember that the angle whose trig function value is square root of 2, or for whose cosine function value is square root of 2 over 2, that angle is 45 degrees. Okay, but that is not our answer. Our answer needs to move into the 2nd quadrant. So really, for cosine, this is a reference angle, and we need to put it into the 2nd quadrant. So to do that, we're basically using our reference angle ideas here and saying, all right, my reference angle is 45 degrees. What would this angle here be? Well, that would be 180 minus my reference angle. So for arc cosine of a negative ratio, we'll find our angle and then subtract it from 180. That's all we need to do. Okay, and we can convert that into radians. That's going to end up being 3 pi over 4. Okay, so to actually evaluate an inverse trig function is really straightforward. We're just trying to find the angle whose function value is equal to the ratio that's indicated. And then we just have to be careful when there are negative ratios that we apply our answer into the appropriate quadrant. For sine and arc tangent, we'll put it into quadrant 4. And for arc cosine, we'll put it into quadrant 2.